might be able to feed the world by 2050. That's not too long away. And it's the protein that they're looking for. And when we talk about biofutures and the fact that you can use sugar, the sugar crystal, not just the juice, the sugar crystal as the basis for bio-brewed protein, that's an enormous future. And we're talking about things like milk or egg white. And that's the protein that the rest of the world, and most of the rest of the world that lives to our immediate north, that's where the demand is going to come from. And we're in the box seat to be able to produce that here.
So I think the key thing to know about future foods is that it's as well as, it's not instead of the currently produced, meats and chickens and eggs and milk. So the real issue is that the world's population is predicted to go to 10 billion people within a generation almost, and there's just not enough land, water, fertiliser to feed 10 billion people. So the ability to create a protein source out of something like connecting to a sugar mill and using raw sugar as a feedstock, it's already made. There's no more land required, there's no more changes to irrigation systems and things like that. So to then convert, the raw sugars currently going into beverages or alcohol or foods, the ability to take that, grow a yeast or a fungi or a microorganism to make biomass, which then can extract proteins, is a really efficient way of producing bulk protein that the world needs for people, for animals, for agriculture and other things.
This is a 100-litre fermenter. It works with liquids inside, so a bit like your homebrew system at home or something. But as you can see, it's got this computer control system on the side. It's got different pumps. And so the goal here is precision fermentation. And so we can really finely monitor the different conditions inside this vessel. We can control what gases and things are fed into it. So there's different microbes, like there's one called Pichia, where it consumes one feedstock and then you can actually change and feed it methanol and it will activate a different pathway.
People have been making beer for thousands of years, and so the whole concept of fermentation using yeast to then produce alcohols and other chemical products has been around forever. The precision fermentation piece is where they can look at creating an organism that, say you grow a yeast or you grow a fungi or you grow a microorganism, they genetically modify that yeast so that if it gets shocked with methanol, it can throw out a protein that has particular DNA characteristics the same as milk or eggs or meat. So yeah, there's a lot of laboratory development that's happened over decades, and the world, everywhere in the world now is at this point where they're ready to scale up. So they're definitely proven at a lab scale, some demonstration scale around the world, but there's not many, commercial scale precision fermentation production facilities in the world. So yeah, this project that we're doing here in conjunction with Cauldron and Main Sequence and others, it's sort of cutting edge.
Fifth generation local, Mayor Greg Williamson got a glimpse of the biocommodity future for the sugar industry in America 8 years ago.
It was a very exciting concept because of the fact that we have in Queensland and in Australia the ability to produce a huge amount of sugar here. And Biofutures, the two conferences that I had the privilege of attending in the United States, one in Boston and one in Philadelphia, was about that enormous future. The first one I found was a whole lot of academics talking about what is possible. And I said, unless that changes, unless we got people on the ground, and that's what this Forum 24 is all about, unless we got people with the experience and with the commercial knowledge to actually make this happen, it'll only be just talk fests. And thankfully, the next one I went to was a lot more commercially orientated. So I think we can see now in the future for Australia, in the future for this region, a tremendous opportunity to capitalise on what the whole world is talking about right now, and that's a biofutures, the bio industry.
For more than 22 years, Darryn Rackemann has worked closely with the sugar industry and heads up the research and development of sustainable aviation fuels in the Mackay Pilot Plant site.
We're working on a process starting from the agricultural residue, the bagasse, after it's squeezed out all the sugar. That's a fibre feedstock, which is a lot different to some of the other feedstock routes for producing sustainable aviation fuels. In our process, what we first need to do is to break that fibre down into small liquid chemical compounds. We then aim to build those chemical compounds back up into a carbon chain length that's suitable to be converted to a fuel. The last part of the step is to remove any oxygen so that we get a very energy dense fuel. It needs to operate under much harsher conditions, such as the low temperature that you see up in the sky. So there's a number of additional properties that it needs to have compared to sustainable diesel.
So this is our hydrotreater. So it's used a lot in the petrochemical industry. That column is actually a pressure vessel. So it goes up to about 3,000 psi. And then we also control the temperature, it goes up to about 350 degrees. If you change some of the seals, it can actually go up to about 500. So very high pressures, very high temperatures. And then we take a feed material, so what we term a biocrude. So in the petrochemical industry, they just use like crude oil, put that in. And then what it does is actually has hydrogen goes in the top, and that reacts, there's a catalyst bed in there, and the hydrogen scavenges any free oxygen from your feedstock, and through the reaction you actually get longer carbon chains, and so that's then what you use for your different fractions of fuels. So the goal with this one is you put your biocrude in, you can create like a renewable diesel with it, and then through the hydrotreating process you can also get a sustainable aviation fuel. We also do a lot with, there's a lot of interest in just demonstrating different milling processes, looking at different ways to use various biomasses. So as part of the upgrade, we're actually hoping to get a twin screw extruder. With that extruder you can actually use it to, you know how you get like the takeaway, the cane fibre cutlery and that type of thing. So you can actually use it to trial that type of stuff.
We've been involved with 3 international companies, Cauldron is one, and they are very, very close to actually making pilot projects. We've actually got the state government very, very close to actually around the Racecourse Sugar Mill, declaring a state development area, and then another state development area down near Rosella, and that's all about a future for the bio-industries. That's all about providing the ability to be right next door to a power source. That's the cogen plant at Racecourse Mill in the sugar industry, right next door to a mill that actually can supply the carbon content. And then once we can prove that concept, then the future is absolutely enormous and very exciting.
Whilst there is a global focus on the biofutures industry, sustainable aviation fuels are currently blended with conventional fuels. Widespread production and use of SAFs is limited by costs and requires significant investment.
Petroleum refining's been there for 50 years, so they've had a lot of time to develop all these technologies and equipment. We're just starting off in the process. We found it's very easy to produce high yields in the laboratory, but it's that next stage, taking it to a pilot plant or a small demonstration plant, that we need to undertake to be able to prove all those economics. And a lot of companies that we work with are in that current stage of trying to raise funds to get those first pilot plants operational. In our case, using agricultural residues, it's slightly less developed than, say, the alcohol to jet route, or using oil crops, or tallow and fats and grease. But one of the things we're trying to do is make our sugar factories more energy efficient, so that we can have lots of bagasse feedstock to make other commodities. Sustainable aviation fuels is just one of them. But it's something that we need because some of these other routes, whether it's from alcohol, whether it's from tallow or oil crops, there's not enough feedstock out there to produce all the sustainable aviation fuels that we need.
Developing new resource production and consumption models requires sustainable processes to ensure a viable future. Reusing and recycling materials and byproducts to extend economic benefits.
The alternative protein, they'll have different yields for different processes, but it could be as low as like 5% yield up to maybe 15%, but it means that that's the alternative to an egg or a chicken or a beef patty, so to speak. But you still have all of the biomass in the yeast, so the remainder of that yeast contains energy, it contains protein, it contains nutrient that is useful. So the plant has to be balanced. So we have to, in this facility, not only provide, alternative proteins that meet the quality specifications. They're dried down to 8% moisture. You put them in a bag as a powder so you can send them around the country or around the world. But you've then got all this yeast co-product in this platform. Others will have a fungi-based platform, others will have an algae-based platform, others will have a microorganism. But the ability to, say, take the co-product yeast and develop it into a feedstock for animal feed or aquaculture feed is really important. So the commerciality again relies on you not paying to get rid of waste products, but getting revenue from your main product and revenue from your co-products. So if you look at where we're located, there's some feedlots here. There's quite a burgeoning cattle industry. We've got Tassal down the road with a 5,000 tonne per annum prawn farm. We've got a barramundi farm. So in the aquaculture industry, the ability to get wild-caught proteins will probably, at a sustainability level, be curtailed in the future. So if you could produce or have an ingredient to a protein source for prawns or fish aquaculture, then that's obviously solving another circular economy problem. So as all of these things, the more and more processes you add on, the more reliance you are on other people, the more cost, but that's the balance. And so commerciality is really, people talk about circular economy, what does it mean? In this case, it means that you use all of the feedstock and all of the available energy as cheaply and as efficiently as you can. And then on all of the waste product side, you can recycle all of your waters, you can contain, not have runoff, not have anything that costs money to process, and then all the co-product gets used up and put into, ideally, a circle that goes back out and feeds cattle, so more cattle can be produced for food.
A couple of benefits that I can see. The fact that young people, young farming people, might be able to see, hey, hang on, we can actually do something to feed the world with sugarcane. It's not just growing it to put in Coca-Cola or something like that. It's growing it for a carbon content to feed the world. Growers will grow it as long as they're going to get a price per tonne that they can actually grow it profitably for. And so that's the challenge. That's the challenge for the industry. That's the challenge for the state government. That's the challenge for the bio-brew industry sector, to be able to make it a marketable product and yet return a profit to everybody in the chain. It requires a whole of Australia approach, a whole of government approach in the state and federal and local government. Competitively, I think we're there. We've just got to make sure that we get the right sort of players on board. Already in Kentucky now, there's a pilot project plant being constructed now to produce milk from a carbon content. It could be the carbon content supplied by sugar, and that's what we need to be on the front foot to be able to do.